perfect. Okay, let me just close this here. And okay, so thank you for organizing this, Jimmy. I think that this is amazing to have these 2 days to talk about the intersection between visual AI and agriculture. So I'm a passionate about agriculture, and today I will talk about FiftyOne and some of use cases in agriculture. We will talk about beyond the lab. We have a lot of real world data sets coming and how we can implement algorithms on that. So my background is in computer vision, so I have a PhD in computer vision, and I have been working in AI for a while. Also the intersection with agriculture. I was working 17 years of my life in agriculture, and I'm super happy to have this conversation with you. I'm passionate about coffee, and I try to bring ideas about how we can improve pipelines and problems that we have for coffee farmers or technicians that are working in the field. You can download the presentation scanning this QR code in the middle. You can also follow me on LinkedIn if you want to continue the conversation, and also join our community. We have a Discord community that's great. If you are a user of FiftyOne, or if you after this talk you can see that FiftyOne is good for you and your project, you need to join our community, and we can continue the conversation there. So let's start with the definition. So what anomaly detection is not just about spotting deficiencies or abnormalities. It is about to identify the unexpected. So something that maybe we haven't added in our training data sets so that we can find there. Normally we talk about anomaly detection in manufacturing or maybe in healthcare. These are the main 2 topics when we can see anomaly detection. So in manufacturing, for example, that means detecting defects, rare events, or outliers. So with different root causes and implications. So, but what we can see in agriculture. So in agriculture, maybe, we can use anomaly detection algorithms. This is a question mark that we have, and we will see the answer at the end of this talk. So what anomaly detection means in agriculture. So we can talk about maybe point anomalies like an outliner pixels. We can talk about contextual abnormalities like a disease level under certain weather conditions, for example. And also we can talk about collective anomalies, like unexpected distribution shift in a crop batch. But we will talk about today what we can do with some images that we are taking in the field. So maybe we will be more focused on contextual anomalies in that case. So, and what is the unexpected in agriculture? If we have a crop and we can see maybe a severe disease leaf, or we can see a partially eaten leaf, or we can see like a normal data point or distribution of the normal data that we are expecting to see. So let's be focused on that. And when we have anomaly detection, maybe we have a common methods working, and we don't know maybe what is working in agriculture. We know that maybe those are working in manufacturing, healthcare. But let's see that these key methods in visual anomaly detection are based on embedding-based methods like a PaDiM, PathCore, FastFlow. I'm just adding some names about some algorithms that we have in anomaly detection, state of the art. So we can also see reconstruction-based methods as autoencoders or GANs. And also we can see one-class classification approaches that those kind of methods are winning more space in the field, because we can talk about clip or zero-shot classifications with another kind of algorithms. So, but I think that if you are familiar with agriculture and you are familiar with, these kind of problems in the field with leaf detection, disease detection, pest detection, normally we are using classification. So, and I think that also we need to be clear about the comparison in between anomaly detection versus classification. So in anomaly detection, we basically we have no labels for abnormalities. We just know the normal status of the elements or leaves in this case. We are also modeling in the normality. So we have just what is the normality, maybe the real distribution of where the normal information is. And the evaluation metrics are also different. We have more Auroch Pro that pixel level information as we have in the classification. So we have a lot of challenges and opportunities. We have in agriculture, we have high variability. We have different crops. We have different seasons. We have lighting conditions. We cannot control lighting conditions. And we have a lot of environmental factors. We have also, we can identify abnormalities. Maybe we need to identify early stage disease that maybe look so similar to the healthy tissue that we have. And we have a few samples of rare disease or pest. So we don't have a lot of information about the abnormalities. And this is where the anomaly detection methods are winning more and more space. So we have also a lot of changes because we are talking about geographic and temporal shifts, and domain adaptation challenges when we deploy in new regions, new crops, and we have opportunities. These opportunities are related with the early disease detection. Maybe also we can monitoring supply chains, automate quality control in the field, and also have more control for this precision agriculture and sustainability. So let's talk about that. We have, traditional approaches often assume that the world is Gaussian, so symmetrical, clean, and predictable. But anomalies are not Gaussian. So, and we need to take a look of multiple techniques like student-teacher networks, memory banks, contrastive learning. But we have, different kind of trade-offs in every single method: complexity, interpretability, and robustness. So I'm working also in the intersection with manufacturing, and I love PaDiM model. I want to bring PaDiM model as well this time. And just a little definition, what PaDiM is a patch distribution modeling framework for anomaly detection and localization. So this model implements the PaDiM algorithm for anomaly detection and localization and make a distribution of patch embeddings at each spatial location using multivariate Gaussian distribution. So I don't want to overcomplicate the definition. So I want to say that basically what we are doing with PaDiM, we are extracting, we are using a pre-trained CNN that extract features. So we apply dimensionality reduction, compute Mahala noise distances to identify those abnormalities based in a threshold that we are also defining in the hard code. So just think of it as, modeling normal looks like, so the abnormal stands out. So this is the idea of PaDiM. This is working pretty well in manufacturing. So what we have in manufacturing is we have is not a biological element, is not growing in the field. We have in manufacturing, we have exactly the same background. We can control light, the lighting conditions. We can control the camera distance. We can control a lot of elements, and we can see, okay, this is working pretty well. But what happened when we bring new data sets to this field? And we will use these data sets for this example. We will provide you also, right now you can scan this QR code. You have access to my Hugging Face hub where I have already those data sets in FiftyOne format. And basically we have two kinds of data sets here. One is called Rocole, where we have Robusta coffee leaves images. You can see the leaf, the complete leaf in the images. And we have normal and abnormal images. So basically you have healthy and unhealthy leaves. And also we have the JMU-Ben coffee dataset that are more related with patches, where basically we are forcing the segmentation of the leaves in multiple tiles. And we will see which approach is better and where the challenges are. So also you can take a look of the papers of these datasets, and you can understand better, the nature of these data sets and, the conditions that they also were using to have this data set. But this is super close to the reality. This is no, they are not controlling light. They have different kind of sizes of leaves. And I think that this is the closest data set that we can see to detect disease in coffee. So how we can see this anomaly detection with unsupervised training in agriculture. So as you can see here in this slide, we have abnormal image, and we have anomaly-free, normal image. So if we pass this through the anomaly detection system, that is PaDiM in this case, we can see like a heat map where we can see where the anomaly areas and pixels are in the output. So for sure in the anomaly map, for the abnormality, we can see like a hot spots, but even those hot spots are out of the leaf. That means that the abnormality is not coming directly from the object. And this is the main challenge that we have for anomaly detection. So with anomaly detection algorithms, we need to control a lot of stuff in our scenario. So basically, if we want to increase the variability of the background, we need to include a lot of information in the training data set. But this is the point. Maybe we don't have that capability to have this information ready. So we have two options. So, and here you can start see what FiftyOne is. I will explain that later. But we have two options. The first option is we can pre-process the information to match the heat map area with the leaf. We can process, we can add multiple kind of algorithms. And because as you can see here in these videos, so we have the abnormal image, we can see how this is matching for sure with the abnormality. But when we are running the normal image, we can see how some hotspots are coming out of the leaf. And we need to avoid these kind of problems. The first option is just pre-process the information, try to create a segmentation mask to reduce that problem. Another option that we have is to tile your images to match in small squares and process small squares instead of the whole images. So we will have more homogeneous information in those tiles. We will see which is better. So first, let me talk about FiftyOne. What FiftyOne is FiftyOne is a platform, is the unique Data-Centric AI platform, open source platform, where you can curate, visualize, and analyze data sets. You can streamline annotations workflows. You can fix and find labeling mistakes, and you can identify and correct model failures. In this video, you can see how I was playing with the platform, where we can see here in the left side, we have the metadata, all the metadata that we have in the data. We have also the visualizer, the visualization of the information is here, where we can see all the process. We can see also the heat map of my anomaly process, the segmentation mask of my anomaly detection. I can play with that. I can also see model evaluation, and it will show you that later. So FiftyOne has a main role in the data-centric AI approach. We have FiftyOne, as I mentioned before. You can manage a lot of steps for the data, for the data set itself. You can also control a lot of, or fix a lot of annotation mistakes, identify those annotation mistakes, and also see the performance of your model and where the models are failing. But we have multiple integrations with FiftyOne. So FiftyOne, if you already have your training pipeline, you can integrate the training pipeline with FiftyOne. it's not just a platform from data annotation and model evaluation. You can integrate multiple things, and I will show you at the end how FiftyOne fits with the data to production pipeline. So in FiftyOne, we have something that is really important that is called FiftyOne Brain, where basically we have a lot of tools and elements where you can gain insights from your data set. So basically, you can extract embeddings, and with the embeddings, you can analyze multiple indexes. You can find similarity, you can find duplicity, you can find a lot of things. So, but in this case, we will use embeddings over patches, and I will show you that in a moment. So FiftyOne also provide you the opportunity to explore your data sets. And FiftyOne, as I showed you before, is an app. You know, we have the GUI, the graphic user interface, but also FiftyOne is an SDK. So the SDK is the software developer kit. So that basically you can access programmatically all the tasks that you want to implement with FiftyOne. You want to load a data set, you need to use the SDK. You can run the compute visualization to extract embeddings from your data set. You need to use the SDK. So basically everything that you can visualize in the app, you need to do programmatically using the SDK. So let's take a look of this video where basically what I'm doing here, I was collecting the patches. So I was running SAM2, and I was also detecting some patches or automatic patches on my data set because I wanted to create this the whole segmentation mask, you know. But when I was running SAM2, segment anything model 2, so the algorithm was detecting small areas, not in the center of the image, maybe in the corner. I needed to see the whole leaf. And I was able to identify the whole leaf in the embeddings of my patches. So I was able to calculate the embeddings of my patches. And with the embeddings of my patches, I was able to identify the whole leaf. And this is a really, really powerful tool because we can we can polish the data set that we need for training. And this is a really nice way to explore a data set. With this, for example, with this data set, with this segmentation mask, I can again prompt my whole data set with segment anything model 2 and find the whole leaves in the whole data set. So I will say we have dataset exploration at all levels. Why? Because we can explore raw data, we can explore annotations if we have, and we can explore the predictions of our models. So what I was doing there, I already mentioned that I was using segment anything model, where basically I wanted to prompt my whole data set with some pre-samples or some samples of my previous usage of segment anything model 2. So what I was doing is using model zoo from FiftyOne. So FiftyOne has an amazing model zoo and dataset zoo, where basically you have a lot of pre-trained models that you can use. And I was using segment anything model zoo, SAM2. I just load the model from load zoo model. I called SAM2, and I apply the model to the whole data set, prompting my model. I didn't prompt the model at all. I just applied this auto. And when I applied this auto, I could see, you know, these kind of small pieces detected because I just make this automatically. So in SAM2 was just trying to find something there, some objects that are coming from the model itself. So I applied SAM2, I generated the mask predictions, and I was able to visualize the results. So what happened there is we can see that we have, when we apply this auto, the thing that I was doing, you can see a lot of small pieces. When I just filter this, I try to, you know, extract those embeddings, filter the detections, and, you know, apply maybe size, shape, and position filters. I was able to identify the whole, just one. and the whole mask for the leaves. So I was able also to run the anomaly detection model with PaDiM using Anomaly. That is a platform, it's an open source, where is basically you have around 15 algorithms that you can run and train and validate your anomaly detection algorithms. I was using that with the whole pipeline that I showed you. And I was able to see, okay, this is abnormal. So you can see here the prediction and also the ground truth. When I was there and I evaluate that, so you can see here, I will stop the video. So we have correct detections. The data set is 2,330 samples, and I have 1,600 samples that were detected correctly. And I have more than 700 mistakes. That is too much. That is too much to have that amount. But when I try to take a look of that, and I see, okay, let me see through the confusion matrix. So this is an interactive plot. So I was able to click on the confusion matrix, and I was able to take a look what is going on with those errors and those problems. So the problem on that is, even if I create the mask, the system was not able to extract or eliminate those mistakes, and the algorithm was detecting normal images as abnormal images, because all the challenges that we have with that specific data set is too complex, this data set. So what if we can tile the images and match with small squares? We can simplify the problem. We don't have this problem with the background. And the model evaluation, I was using exactly the same algorithm. So I was training my model. And as you can see here, we have almost the whole data set was correct. Almost all. I have just one mistake here. So in that case, we are using this tile small squares. So we were able to identify healthy and minor presence in the images. So and as you can see here in the model evaluation panel, you can also interact with the confusion metrics. You can interact with the class performance. You have a lot of capabilities with this. So, but it's challenging. We need to simplify the problem. We cannot see or have uncontrolled conditions in the data set. So we need to simplify this as much as we can. So we have a lot of problems in the agriculture because we have images coming from outdoor conditions. We have shadows, we have occlusions, we have a lot of lighting conditions. If it's we have sun or different kind of lighting conditions or camera, but we can solve this problem with anomaly detection. And for sure, we don't have a lot of annotations. So we don't need annotations in the anomaly detection algorithms. This is unsupervised learning. So if you know what is the normal and you can create or simplify the representation of the data set, you can solve the problem. So we need to have, apply this to different crops. We need to also include multimodality. And for sure, we need to activate different kind of infrastructure to run this kind at scale. So my recommendation here, so we need to make a choice in between model-centric approach and data-centric approach. So data-centric approach is the way, because we can reduce the bias and errors. We can understand why this problem is happening. It's not just say anomaly detection is not working for agriculture. No, how we can make this work for agriculture. So it's, because we understand right now what is the reaction of the data set with these kind of algorithms, we can improve that pipeline and we can increase the quality of the data set, and we can create like a cost-efficient optimization. So how FiftyOne fits in this data to production pipeline. So basically you can You could have data exploration and evaluation with FiftyOne. You can also include image correction, annotation, and augmentation with another kind of tools that we have tons of integrations with multiple libraries. You can also run the training. You can also run the training pipeline if you are running using Python. You can also use the model evaluation natively in FiftyOne. And you can also test, continually testing and validating your model and monitor the model directly in FiftyOne. So we have, and we are so proud to be, at Voxel 51 to have this coherent visual AI platform where you could have a lot of benefits: time efficiency, cost reduction, accuracy improvement, and answer enhancement for these decision makers. What is going on with, finally, yes, we are processing images, but we need to activate some machine learning algorithms to extrapolate those to the field. It's always great to see how we can touch these benefits. And Voxel 51, so we are the lead maintainers of the open source project 51, and we are making visual AI a reality. So if you want, you can explore, you can visit our documentation. So it's easy, it's super easy. You don't need to subscribe, you just need to pip install 51 in your laptop or in your server. You can try tutorials, you can join our community, and also stay tuned because we have a lot of events. So Jimmy already mentioned this. October the 28th, we have the Getting Started experience with 51, where we can also explore what kind of things we make today deeper. And we have also a lot of in-person meetups coming. So we have the Iowa in November the 6th. And we have also in Raleigh, this is that was no, I didn't think about that, but we have 3 talks about agriculture, so that will be great if you are in the area and you want to join me in Raleigh to see more agricultural stuff. Thank you so much.